Example 7. An experiment consists of drawing one card from a standard 52 card deck. What is the probability of drawing a black card, a numbered card, an ace, a red queen, or a 6 or a spade? Okay, so we're going to handle each of these issues separately. Okay, so remember what's going on here. You've got one deck of cards, standard deck of cards. So say the cards are face down, they've been shuffled, mixed up, and you go up to the deck of cards and you draw one single card. Okay, so we're trying to compute what is the probability of drawing the card that is stated. Okay, all right, so if you were to mix up all the cards, it's gonna, and you go pull a card, these are equally likely outcomes. Okay, one card is just as likely as pulling another. Okay, so you don't have to worry about there. It's all equally likely outcomes. Okay, so we're going to apply the basic probability principle here, where the top number is going to be the number of cards in this case that meet our criteria, and then the bottom number is going to be the total number of possible outcomes. Okay, so if you're thinking, let's first think about the denominator. Okay, so remember, you're drawing from a standard deck of cards. There's 52 cards in the deck. Okay, so those are all the possible cards you can draw. So the bottom number for all of these parts, okay, is going to be 52. Okay, and then I'll write for D and E when I get down there. Okay, so total possible number of outcomes, 52 here, the entire deck of cards. All right, so we just need to work on the top numbers here. Okay, so we need to go to our deck of cards and we'll go and refer to the picture. But how many of the cards are black cards? Okay, so if you go back and you look at your deck of cards, picture that I gave you, if you need to look at a picture, you know that there's 52 cards in the deck. Half of them are black and half of them are red. And, you know, you can also count it pretty easily here because you know that there's 13 in each suit. So there's 13 clubs and there's 13 aces. And so 13 plus 13 is going to be 26. So there's 26 black cards and 26 red cards. 26 plus 26 is the full deck 52 cards. Okay, so going back to our problem here, okay, 26 of the cards are black out of the whole deck of 52 cards. Okay, you can leave the answer like this. Okay, if you reduce the fraction, it is 1/2, which makes sense because half of the deck is black. Okay, you can also express this as 0.5. Okay, there's your probability. Okay, all right, so as far as interpreting this, okay, you know, if you take this decimal and you think of it as a percentage, 0.5 is 50%. If you go and draw a card from the deck, 50% of the time you're going to draw a black card. Okay, that's how you can make sense of probability. Okay, in this particular situation. All right, moving on to part B. Okay, what is the probability that the card you draw is a numbered card? Okay, so all we need to do is go back to our deck and figure out how many of these cards meet that criteria. Okay, so let's look at all the numbers. Okay, so for each suit, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 cards that are numbered. Okay, and that's for each suit. So if you did that 9 per suit, 4 suits, so 9 times 4 is going to be 36. Okay, so there are 36 numbered cards. Okay, so your probability is going to be 36 out of 52. Okay, you can choose whether or not to reduce that. Okay, I will go ahead and do that for you. Either answer is acceptable, reduced or not. Okay, both of these numbers are divisible by 4. Okay, so 36 divided by 4 is 9. 52 divided by 4 is 13. Okay, so either way you want to do it, that's fine. Okay. All right. Let's talk ace. Okay. So what's the probability of going up to the deck of cards and drawing the single card that you draw is an ace? Okay. So we need to go to the deck. Okay. We need to look at it from the perspective of how many of these cards are aces. Okay. And that should be pretty easy to count up. Okay. All the aces are over here. Okay. There's 4 aces in the deck. Okay, so our probability is going to be 4 out of 52. Okay, you can reduce this, okay, if you choose to. All right, both of these numbers are divisible by 4. 4 goes into 4 one time, 4 goes into 52 13 times. Okay, so there's your probability. Okay, all right. Next, what is the probability that the card you draw is a red queen? Okay, might want to check a picture for this one in case it helps. Look at your deck of cards and how many red queens do you see? Okay, well, here's my queens column. There's 4 queens in the deck. Okay, the red ones are the Queen of Hearts and the Queen of Diamonds. Okay, so there's 2 red queens in the entire deck. Okay, so this problem is going to be this probability is going to be 2 out of 52. Okay, 52 total cards in the deck, and then 2 of them meet our criteria. Okay, you can certainly reduce this to 1 over 26 if you wish. Okay, I'll even make a note right here. This is going to be the Queen of Hearts and the Queen of Diamonds that we're talking about. Okay, all right, last, and this one might be a little bit tricky. Okay, now we want the probability of drawing a 6 or a spade. Okay, so remember, or language means U for union. Okay, so that means, either of these conditions will suffice. Okay, so to be counted, it either needs to be a 6 or a spade. Okay, so let's go count how many of the cards meet this criteria. The bottom number is still going to be 52. Okay, so we're looking for a 6 or a spade. Okay, let's start with well, let's just circle what we're looking for. I'll put it in red. Okay, so your card can be a spade. Okay, so here is the row that has all spades. Okay, your card also could be a 6 to fit this bill. Okay, so I'm circling everything that meets that criteria. We've got 1 column and 1 row meeting the criteria. Okay, so how many cards are we talking about total? Notice that the 6 of spades falls in both categories. You don't want to double count it. Okay, you only count 6 of spades one time. So I'm going to count how many cards are circled here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 16 of the cards are either a 6 or a spade. Okay, so the top number here is going to be 16. Okay, so once again, you can reduce this if you choose to. Okay, 4 goes into both numbers. 4 goes into 16 4 times. 4 goes into 52 13 times. Okay, so there is your probability. Okay, this was just a simple application of the basic probability principle.